Okay, in this lesson we're going to look at graphing trigonometric functions again, in this case reflection across the y-axis. Let me just get rid of that. And the key here, really simple, if we multiply the argument by -1, that's going to reflect the graph across the y-axis. So multiplying the argument by -1 is going to reflect the graph across the y-axis. So here's my, suppose I have a function sine of x. Okay, suppose there's my function f of x equals sine of x. Well, we're going to say that if we take a -1 and we multiply it by that argument to make it f of x equals sine of -x, well, that's going to reflect the graph across the y-axis. So in the previous graph, in the first graph we looked at, every point is going to be of the form x comma sine of x, and now every point is going to be of the form x comma sine of -x. Okay, so let's look at that with a GeoGebra file. I've one kind of set up here. I've set up a slider with just two settings on it, 1 and -1. There's my graph. You can see there's my graph of my trigonometric function. It's the sine function. You can see there it's sine of 1x, and I'll just put that out there. So sine of 1x, or just sine of x. Y-intercept at 0, increasing. Also it's a concave down, or a sad face. Increasing, still a sad face. Then we get to our maximum value here at 1, when x is pi over 2. And then it starts decreasing, still a sad face, or a concave down section of the curve here. And then we have a root here at pi, and there's a change in concavity to a happy face, or a concave upwards function. That means that point there, that root, is a point of inflection. The function is still decreasing, and down here we have a minimum point when x is 3 pi over 2, or 270 degrees. The output, the value of the function is -1, then it's increasing, still happy face, still concave upwards, and then another root here at 2 pi. So what I'm going to do is I'm going to just change that 1 to a -1 by just taking my slider and changing it to its other position. And there's the function f of x equals sine inverse of x. So what I want you to see is that this function, when we put the negative in front of the argument, the function kind of reflects across the y-axis. So it kind of reflects across the y-axis. That's the key detail. Okay, it's reflecting across the y-axis. And it's hard to see that really with the sine function, because it looks like it might be reflecting across the x-axis here, but actually we say it's reflecting across the y-axis. If I put in a different function, for example, the function 2 to the power of x, that's what the function 2 to the power of x looks like. When x is 0, 2 to the power of 0 is 1. If I change that now to 2 to the power of -x, you'll see that has reflected across the y-axis, not the x-axis. Okay, so the key takeaway here, the key detail, is multiplying the argument by -1 reflects the graph across the y-axis. Reflects it across the y-axis, not across the x-axis, across the y-axis. So multiplying the argument by, multiplying the argument by -1 reflects the graph across the y-axis. Okay, learn it, practice, try setting it up on GeoGebra. Make sure you know that rule. You just gotta know it. It's as simple as that.